the we've got a soccer ball on a cliff that is h meters tall, and the initial velocity is v naught, and it's at an angle to the horizontal of theta, and we are trying to calculate the max height of the ball relative to the ground. So first we know that the initial and the y is equal to v naught sine of theta, and we know that velocity final in the y is equal to 0, because that's where it says max height and it is no longer moving upwards or downwards at that moment. So we are going to use the formula v of t is equal to v initial plus a t, and we can plug in v of t is going to be v final, so 0 is equal to v initial v naught sine of theta plus a is going to be negative g, where g is the acceleration due to gravity, which is 9.8 meters per second squared, and then t, because that's what we're looking for. And so we can then solve that. We subtract the initial velocity over, and then we can solve for t, which is v naught sine theta over g. So that's the time it takes to get to its maximum height. And then we can use the formula y of t is equal to y initial plus v initial in the y times t plus 1/2 the acceleration times the time squared. And we can plug in y is equal to h, because it's originally h meters from the ground, plus v initial, which is v naught sine of theta, times v naught sine of theta over g, which is the time it takes to get to its maximum height, plus 1/2 negative g times v naught sine of theta over g squared, which we can then solve out to be y is equal to h plus v naught squared sine squared of theta over g minus 1/2 v naught squared sine squared of theta over g, which then goes to h plus 1/2 v naught squared sine squared of theta over g, which is the height at its maximum. That's the maximum height relative to the ground. Then from there we can calculate how far the ball will travel in the x direction before reaching the ground. We know that the velocity initial in the y direction is equal to v naught sine theta and we do not know the velocity final in the y direction. V final in the y direction, we do not know that. We know that the initial height is h, and we know that the final height is 0 as it reaches the ground. From there we can calculate the average velocity in the y, which is equal to delta y over delta t, which is equal to y final minus y initial over delta t, which is equal to 0 minus h over delta t. And we're going to call this star. We're going to plug in for it later. And then we have another formula for the average velocity in the y direction, which is v initial in the y plus v final in the y over 2, which we can solve for, is v naught sine of theta plus the final velocity in the y direction over 2, and we're going to call this 2 star because we're going to solve for it, plug in for it later. Then we have the momentum formula, which is final momentum in the y direction is equal to the initial momentum in the y direction plus the force in the y direction times delta t. And we can solve, we know that momentum is mass times the velocity, so final velocity in the y is equal to mass times the initial velocity in the y plus force in the y is going to be equal to mass times negative g times delta t, which then we can solve, if we solve for the final velocity in the y direction, we get v final in y is equal to v initial in the y minus g delta t, which is equal to v naught sine theta minus g delta t. Then we have to plug in to 2 star, and we get v average in the y is equal to v naught sine of theta plus the final velocity in the y, which we just solved for, v naught sine theta minus g delta t over 2. And then from there we solve for that, and we get that the v average in the y direction is equal to v naught sine theta minus 1/2 g delta t, which we then plug into 1 star, and we get v naught sine theta minus 1/2 g delta t is equal to negative h over delta t, and we then solve out to get 0 on this side. We get to get 0 on this side, and we say that negative 1/2 g delta t squared plus v naught sine theta delta t plus h is equal to 0. And then we use the quadratic formula to solve for delta t. So delta t is equal to negative v naught sine theta plus or minus the square root of v naught sine theta squared minus 4 times negative 1/2 g, so plus 2g times h over negative g. And then because we want a positive t, we're going to say delta t is equal to v naught sine theta plus the square root of v naught squared sine squared of theta plus 2gh over g, which then we're going to call this 3 star. And now we're going to consider the x direction of motion, and we're going to say the average velocity in the x direction is constant, and so v initial in the x is equal to v final in the x is equal to v naught cosine of theta. And another formula for the direction, or the average velocity in the x direction, is the change in x over the change in time. And from there we can say delta x is equal to the v avg, v average in the x direction, times delta t, which is equal to v naught cosine of theta times delta t. But we solved for delta t up here, and we're going to plug that value for delta t back into this. And so we get delta x is equal to v naught cosine of theta times v naught sine of theta plus the square root of v naught squared sine squared of theta plus 2gh over g, which is the distance traveled in the x direction before it reaches the ground.